All right, I hope you find this helpful. What we're going to do here is we're going to go through the um, problems that I gave you on your worksheet today. So take a look here, and we will go through these. I'll use a highlighter here. Um, so again, decide by going to the left side because I've got more stuff to work with. And my first step up here is going to be changing everything into sine and cosine. Okay. Then I have a common denominator here of cosine, so I can write step 2, 1 minus sine squared over cosine. Okay, and then I do a direct substitution. 1 minus sine squared. By definition, that's one of our definitions, our trig identities. That's cosine squared. So now that's my numerator. Cosine x remains my denominator, and then I can cancel. And then in step 4, that leaves me with cosine x. And I keep looking. Well, how do I get to that to 1 over secant? And I go ahead and say, well, that is the reciprocal. That's so 1 over secant is cosine x. Let's go to number 2. 2 is a quickie as far as I took the right-hand side here and said, okay, well, how can I write cosecant? Well, that's 1 over sine. How can I write cotangent? That's cosine over sine. Okay. And then I look back and I look back to the left up here, 1 plus cosine x over sine x, and I say, okay, well now if I just write this as one denominator of sine, just change the format here a little bit, I get the 1 plus cosine over sine. And that's it for that one. That's quick one. Okay. Let's go to number 3, one of the tough ones. Okay. For number 3, okay, I'm going to start with the left-hand side. Oops. And rewrite everything 1 over cosine here for secant on the top. And the bottom, I'm just going to write in terms of sines and cosines. Okay. Now I want to make the common denominator here of cosine and sine. Well, how do I do that? That means I need to multiply by, let's go ahead and put this in red. I want to multiply by cosine over cosine here. Or excuse me, sine, dag on it. Sine over sine here. And then over here, the denominator is missing cosine, so cosine there. Okay, do that multiplication, and I get over to here. Top is just sine over cosine. Okay. And the bottom, now sine times sine is sine squared. Cosine times cosine is cosine squared. And the denominator is cosine times sine. Okay. Then, okay, the top stays the same. And the bottom, sine squared plus cosine squared is 1. And then on the bottom, cosine sine. Okay. Now I'm in that fraction that I know what to do. I'm going to flip and multiply. And so that gives me this sine over cosine times the reciprocal, which is that. And then I do my cancellation, and I get sine squared. Okay, play that back if you need to, but that's number 3. And again, the key is making the like denominator down here in the denominator to start. Number 4. Number 4. We want to go ahead and a couple ways of doing this. I went ahead. The one I'm posting here is starting with 1 over cosine for secant. Leave the cosine as it is. And I went ahead and left the tangents here, which I don't often do, but I did that to start here. Because now, when I flip and multiply here with the cosine, I'm going to take this left and right side separately. This is the next thing right here. 1 over cosine squared x, because if I take the reciprocal of cosine x, my denominator, it's 1 over cosine x. Okay. Same thing kind of happens with the tangents, except I get both tangents on the top, and I have that. Okay. Now, I kind of waited to there to substitute. Some of you have this all in terms of sines and cosines, and that's perfectly fine. Uh, so now, 1 over cosine squared x minus tangent is the same as sine over cosine. Now that's a glorious thing because now I have a common denominator of cosine squared x, and then I squish this together. In other words, I rewrite in terms of the denominator there. And now I need to know that 1 minus sine squared is cosine squared. So now I got cosine squared over cosine squared, which is by definition 1. And that's number 4. Let's move to number 5. Number 5 is pretty quick. It's a direct substitution. Cosine squared is by definition 1 minus sine squared. Now I've got 1 minus sine squared, and I get 1 minus 2 of those, 2 sine squared y's. And again, whether they use y, theta, or x doesn't really matter. That's all unknown angle. Okay? That's all that means. Okay. Let's move to number 6. Number 6. Okay. Starting off here on the left-hand side because I got more stuff. Let's make this in terms of sines and cosines. 1 over sine squared for cosecant squared. Sine squared over cosine squared for tangent squared. Minus 1 is still happening, right? So I still need to write that minus 1. And because this is multiplication right here, I can cancel. So now the sine squareds cancel, and I get 1 over cosine squared. And again, now on my paper, when I did this the first time through, at this point right here, I went ahead and I made a like denominator of cosine squared over cosine squared in place of this 1 here on the right. Okay, but hopefully, when I looked at it a second time, I said, okay, 1 minus cosine squared, that's secant squared x. And then secant squared x minus 1 is very close to my one of my Pythagorean identities, which is tan squared theta plus 1. You just subtract 1 from both sides, and then you can say that that is tangent squared x. Okay? And the identity I was using was this guy right here. Okay? Let's go to number 7. Okay? So I'm going to start with the left-hand side. And first substitution is secant squared x minus 1 again. That's going to be tangent squared. Then I say, well, I got secants and tangents. Don't like that at all, so I'm going to turn it into sines and cosines. So that's the top, 1 over cosine squared. And the bottom is sine squared x over cosine squared x. Now in that fraction, hopefully we know what to do at this point. We're going to flip and multiply. Okay. Cosine squared x cancels. And I get 1 over sine squared x. Yay! That's cosecant squared x. Okay. On to the very last one, which is, a little bit more challenging. So starting out, I started on the right-hand side for this one. Okay. So I said, okay, well, let's take this thing and go, okay, turn everything into sines and cosines. That's what we did. And now I say right here, I need a like denominator, so I need to multiply by cosine squared over cosine squared. Okay, and I see where that takes me. And it's not a beautiful place. It's here. Woo! I do that for me. Gets me to here as I multiply there, right? So when I look at this expression right here, the only thing I can really do there is factor. Okay, that's really it. In other words, I can rewrite this as sine squared x because there's sine squared x in both of those terms up on the top. Sine squared x divided by sine squared x is 1. Sine squared x cosine squared x divided by sine squared x is cosine squared x. So that's factoring right there. It's been a while since we've factored anything, but that's factoring right there. Now, 1 minus cosine squared x, ding, 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 that's sine squared x. Here, the second one there. And now I keep looking back up to this top left and saying, well, what do I got here? And then I say, well, sine squared over cosine squared, that must be tangent squared. And then I've got this sine squared left over. Okay? I wrote the wrong thing here. Should be okay. Right there. All right. All right. So those are the 8 problems that we used for verifying trig identities. Again, so these were all verifications where we basically took the left side and said, let's make that the right-hand side. Hope that you found this helpful, and we will see you tomorrow. Have a great day.